Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you angle of friction, angle of repose, problems on the rough inclined plane, and what is the minimum force required to pull a body on rough surface. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitj exam and NEET exam confidently with a good rank. Now let's start about the class. Today's topics are written here. Angle of friction. First topic is angle of friction. What is angle of friction? Suppose if suppose this is a rough surface, rough ground, and a block is present here. Block is placed on the ground. Now what is the contact force? Contact force is in this direction. This is the contact force. This is the contact force. This is the contact force. Now I have discussed in previous class that a vertical component of this contact force is normal reaction, and this component, that is this component is the friction. This is the friction. Friction is denoted as F, normal reaction N, and this is the contact force, suppose R. Now what is the angle of friction? Angle of friction is this angle. This angle is called angle of friction, which is lambda. Angle of friction is denoted by angle lambda. So this is the contact force. Now a vertical component is normal reaction, and this component is friction. Now angle between normal reaction and contact force is angle of friction. So what we get? To friction force equal to mu into n. So now if we resolve r cos lambda equal to n, if we resolve this, r cos lambda equal to n and r sin lambda equal to friction force. Now mu equal to f by n, so f equal to r sin lambda by n equal to r cos lambda, cancel r, that is tan lambda. So mu equal to, result is tan lambda. So this is the theory, mu equal to tan lambda. Okay, mu equal to tan lambda. So this is the angle of friction. Angle between contact force and normal reaction is angle of friction. So we get mu equal to tan lambda. Next topics. Suppose this is a ground and an inclined plane. This is ground. This is ground. An inclined plane is, this is the inclined plane. Angle of inclination is theta, and a block is placed on this inclined plane. A block is placed on the inclined plane. Now the angle of inclination is less, so that the block does not slide along the inclined plane. The theta is less. Block does not slide, does not slip or move along the plane. Now if theta is increased, angle of inclination is increased gradually, what happens? At a particular angle, the block start to move. The block just to move. When the block just to move or at the point of motion, then that angle is called angle of repose. So angle of repose theta. What is angle of repose? The angle at which the angle theta of inclination at which body placed on the inclined plane just to slide or slip, or at the at the point of motion. That is that the particular angle at which is just to move. Now when theta, suppose theta, so this angle is called, suppose particular angle of repose, suppose this inclination is denoted by, so theta is the general angle. Now what is the angle of repose? Suppose we call alpha. Angle of repose is denoted by, suppose, alpha. Now when theta is angle of inclination, that when theta is less than alpha, then body is at rest. When theta equal to alpha, body is at point of motion, and when theta greater than alpha, the body start to move. The body accelerate with body has an acceleration. So the body has an acceleration. So what is the angle of repose? Here angle of repose, if we denote alpha, and general angle is theta. Theta is gradually increased. So at a particular angle at which the block on the inclined plane just to move or at the point of motion is called angle of repose. So when the angle of inclination is less than alpha, that is angle is less, the body is at rest. Now at the angle of repose, the body just to move, and theta greater than alpha, the body has an acceleration. Body moves with an acceleration over the inclined plane. Suppose a block is present on a plane. Now at the angle alpha, what is the formula? Formula is suppose this block of mass m is rest on the inclined plane, angle of inclination is alpha. Now at this is angle of repose, so at this angle the body is just to slide. Now what is the force acting on this block? Weight act in this direction. This is normal direction n. So if this angle is alpha, then this angle is alpha. So this is mg cos alpha, and this angle, this component is mg sin alpha, and friction force act. So this block just slide along this direction due to this force, due to this component of the weight. Now friction force must act in this direction. Friction force must act in this direction. So here friction force equal to mg sin alpha. Friction force balance this force and n balance this force. So n equal to mg cos alpha. Now what is F by n? We know mu equal to F by n, which is equal to this by this, that is tan alpha, this by this tan alpha. Now mu equal to, we know from the previous problem, tan lambda. So tan lambda equal to tan alpha, that is lambda equal to alpha. So angle of friction and angle of repose will be same. A block of mass m is present, mg act in this direction, mg sin theta act in this direction, and mg cos theta in this direction, and normal direction n direction, and friction force act in this direction. So here we write n equal to mg cos theta, friction force equal to mg sin theta, and static friction equal to mu into n. static friction equal to mu into n with the inclined plane. General angle of inclination is theta, and a block of mass is placed on the inclined plane. Now here, what is the force acting on this body? mg act in this direction, mg sin theta, which is driving force F, and friction force act in this direction, normal direction act in this direction, and this is angle theta. So this is mg cos theta, and normal direction is n, and friction force is equal to mu into n. Now, so F equal to limiting friction. What is the limiting friction? Mu into, we know mu into mu s into n. This is the limiting friction, which is mg cos theta. Now this is the driving force, this is limiting friction, this is the driving force, that is, for this force the body can slide down along the inclined plane. So this is the driving force, which is mg sin theta, and normal direction n equal to mg cos theta. Suppose the angle of inclination is gradually increased, then what happens about the Fn? If so, from this formula we see that limiting friction is proportional to mu into cos theta, because mg is constant, mu into cos theta, and driving force is proportional to sin theta, and normal direction is proportional to cos theta. So as gradually theta is increased, then driving force increases, and normal direction and limiting friction decreases. So at a critical point, when driving force is equal to limiting friction, F equal to Fl, then that angle is called angle of repose. Theta equal to alpha, that is angle of repose. So this way, at a critical point, that is angle of repose, friction force, driving force, and limiting friction will be equal, so that theta equal to alpha. Now what is if we draw the diagram, suppose this axis is along this axis is theta, so theta is plotting along this axis, and this axis friction force, normal direction, and driving force. So at theta equal to 90, what is the formula? F equal to mg sin theta, normal direction equal to mg cos theta, and limiting friction equal to mu s into mg cos theta. Now at theta equal to 90 degree, what happens? Theta equal to 90 degree, this is maximum, so theta equal to friction force is maximum. So F gradually increased, and cos theta is gradually decreased when theta equal to 0 degree, cos this is maximum, normal direction maximum. At theta equal to 90 degree 0, so theta equal to 90 degree 0, this is n, this is friction force, this is driving force, and limiting friction when theta equal to 0, this is at theta equal to 0, this is mg, and theta equal to 0, this is mu mg, and theta equal to 90 degree, this and this. So this is the driving force graph, this is the normal direction graph, and this is the limiting friction FL graph. Because at theta equal to 0 degree, what is this? At theta equal to 0, n equal to mg, and friction force equal to mu mg. So here friction force mu mg and n equal to mg. Proved. At theta equal to 90 degree, suppose this is 90 degree, theta is 90 degree, this equal to 0, this equal to 0, and this is maximum. So this is maximum, this is mg, these and these are equal. So if we plot this along theta, then the graph will be this. This is the graph of driving force, this is the graph of driving force, this is the graph of normal direction, and this is the graph of limiting friction. This is a block, this is a block of mass m. Now if force F is act on the body at an angle theta with the horizontal, and coefficient of friction is mu given. This is coefficient of friction, static friction. Now what is the minimum force required to pull the body? What is the minimum force required to pull the body? This is the question. So now here the motion of the body is opposed by the friction force acting in this direction. This is the static friction. So to solve this problem, we first resolve friction force. We resolve the external force this and this direction. So component is along this is f cos theta, and along this is f sin theta. Weight act in this direction mg, and normal direction act in this direction n. As there is no motion along this direction, then n plus f sin theta balance the weight of the body equal to mg. So from this we get n equal to mg minus f sin theta, normal direction. Now what is the friction force? Friction force act in here, mu into n, that is mu into, this is static friction, so mu s into n. Normal direction is this. Now what is the condition to move the body? What is the condition for motion of the body along this direction? That is this force minimum, this force must be equal to the friction force. This force must be equal to friction force. So f cos theta must be equal to friction force. F cos theta equal to friction force. What is the friction force? Mu s into mg minus f sin theta. This. Now from this we get f common, cos theta plus mu sin theta equal to mu mg. So f equal to, we get f equal to mu So this is the answer. Now here two case, there will be two case when theta is fixed. So understand this problem. Force applied here, we first component this along horizontal and vertical. Horizontal is f cos theta, vertical is f sin theta. Weight act in this direction, normal direction act in this direction. So to move the body, minimum force, horizontal force, body moves with horizontal direction, so the minimum force required, that is f cos theta, must be equal to friction force, so that the body can move in this direction. So to move the body along in this direction, this force must be equal to this force. If this force less than this, then the body cannot move. So to move, minimum condition is that this force equal to this force. If the body, if this force greater than f, then the body can move easily, but minimum force, this must be equal to friction force. So friction force equal to mu into n. What is n? To get n, normally n equal to mg when force is applied complete force is applied along the direction. But if the force is acting at an angle theta, then some component act in the vertical direction, so here n will be changed. N plus f sin theta, balance the weight of the body, so n equal to this. Now put n here, we know f equal to mu into n, put n here, we get this equation. Now shift f sin theta along this left side, this is right side. Now f equal to this by this, so this is the answer. Now when it is an angle, when theta is constant, then minimum force required, we get mu mg by cos theta plus mu sin theta. Now when theta is constant, now when theta is variable, when theta is variable, that is you can vary the theta. Suppose force is applied, we apply the force in this direction, we apply this force in this direction, that is theta varies. Now if you are allowed that you can vary the theta, then what is the minimum force required to pull the body? You are allowed to vary the theta, so you can vary the angle theta. Then what is the minimum force required to pull the body? So when theta is variable, then what is the minimum force? Now here F minimum will be mu mg 1 cos theta plus mu sin theta. Now here in trigonometry, the formula of minimum value of a cos theta plus b sin theta equal to root over a square plus b square. Maximum value, formula of maximum value of a cos theta plus b sin theta is this, root over a square plus 4. This is in trigonometry. In maths, this is the formula, a cos theta plus b sin theta. Maximum of this is this. So here a is 1 and b is mu. Now we find the maximum value of this. So maximum value of denominator, a whole quantity will be minimum. So we find the maximum value of this. So then we get the minimum. Minimum will be mu mg divided by root over a square plus b square, root over 1 plus mu square. Okay, this is the answer. So two answer here for this type of problem. Two answer. When theta is constant, then we get this result. Theta is constant. When theta is constant, we get this result. And when theta is variable, then we get this result. Ball is placed at the top of the inclined plane, angle is theta. Now this time taken is suppose t. This is smooth plane. Now if this inclination, same inclination, this is rough plane, coefficient of friction is mu k, and the length of the inclined plane is s. Here also length of the inclined plane is s. Now the time taken to reach at the ground for the rough surface is n times that of the for smooth surface. That is time taken. If this time taken is t dash, now given t dash equal to n of t, then what is the relation between mu k, theta and n? Find relation between smooth. Surface is smooth. When surface is smooth, then what is the acceleration along the smooth plane? This is g sin theta. Smooth plane acceleration is g sin theta. So use the equation s equal to ut plus half a t square. We get t square equal to 2s by g sin theta. Now for rough surface, we have to calculate the acceleration along inclined plane. What is the acceleration? To find the acceleration along inclined plane, acceleration along rough inclined plane. What is the acceleration along rough inclined plane? What is the acceleration along rough inclined plane? Suppose we calculate this. Suppose this is the inclined plane, angle theta. Suppose a ball is present here, mg sin theta acts in this direction, and friction force act in this direction. Which is equal to mu into n. N equal to mg cos theta. So this is the friction force and driving force is here. So mg sin theta is greater than this, so that block accelerate in this direction. So what is the acceleration? Ma equal to mg sin theta plus mu mg cos theta, that is a equal to g sin theta plus minus mu g cos theta. This is the acceleration along rough inclined plane. This is the acceleration along rough inclined plane. So memorize this formula. To solve the problem, you have to memorize this. Acceleration along rough inclined plane is equal to g sin theta minus mu g cos theta. So when we apply the equation along rough inclined plane, so this is the formula, acceleration equal to this. So for rough inclined plane, same length of the surface is same, s equal to ut plus half a. Now here acceleration is this, g sin theta minus mu g cos theta into time taken is nt. So from this we get n square t square equal to 2s by g sin theta minus mu g cos theta. Now this is equation 1 and this is equation 2. If we divide 2 by 1, what we get? If we divide 2 by 1, 2 divided by 1, what we get? N square equal to this by this, that is g sin theta by g sin theta minus mu g cos theta. Now g cancel sin theta by 1 minus sin theta minus mu cos theta. So n square equal to this, we get n square equal to this. Now this we get n square equal to n square sin theta minus mu n square cos theta equal to sin theta. So sin theta n square minus 1 equal to mu n square cos theta. So tan theta mu equal to, so mu equal to tan theta divided by this, tan theta by n square, 1 minus 1 by n square. Student, this is the end of the class. To continue the friction theory and to get such type of video, subscribe my channel. Okay, thank you.